Have you ever really thought about what's going on inside an electric motor? It kind of feels like magic, doesn't it? You put electricity in one end and you get motion out the other. Well, today we're going to pull back that curtain and take a look at the invisible engine that powers just about everything, magnetic field energy. So, here's how we're going to break this down. First, we'll look at the motor itself, the engine of everything. Then we'll use a really simple idea, an invisible spring, to understand what's happening. After that, we'll see how energy gets stored in fields, how that field turns into force, and finally how this one concept powers our entire world. All right, let's kick things off with a puzzle that's hiding in plain sight, right at the heart of our modern world. I'm talking about the mystery inside every single motor. I mean, this is the fundamental question, right? Think about it. You plug in a blender, you start up your electric car, you're sending electricity into it, and you're getting motion back out. Spinning blades, turning wheels. But what is that invisible connection? How does electricity actually become a physical force? That is the exact puzzle we're here to solve. Okay, to really wrap our heads around this link, we need a good way to visualize it. So let's think of this whole process like it's an invisible spring. The real question we're asking is, before something actually moves, where is all that energy hiding? You know, it's a basic rule of physics. Before you get movement, what we call kinetic energy, you first have to have stored energy, or potential energy. It's just like drawing back the string on a bow. You're loading energy into the system, getting it ready to be released. And believe it or not, that exact same idea is at work inside every electric motor. To make this crystal clear, let's use a super simple analogy. Just picture a regular rubber band. When it's just sitting there, not much is going on. But the second you start to stretch it, everything changes. Now, here's the fascinating part. If you could zoom way in, you'd realize the energy isn't really in the rubber material. The rubber is just the thing that's holding it all together. So if it's not in the material, where is it? It's stored in the tension, in the strange shape of the rubber band itself. The moment you let go, all that potential energy instantly becomes the kinetic energy of motion. So the key idea here is super simple, but it's really profound. Energy can be stored in tension. Just hold on to that thought for a minute. So what does a rubber band have to do with electricity? Well, this is where it all connects. We're about to see how electricity creates its own kind of invisible tension by storing energy in fields. This is one of the most fundamental, kind of mind-blowing principles in all of physics. Whenever you have an electric current, electrons moving through a wire, it doesn't just go from point A to point B. It also generates this invisible aura of influence all around it. And that is a magnetic field. And this is the light bulb moment. That magnetic field is the electrical version of our stretched rubber band. The current is actually storing potential energy, not in a physical object, but in the tension of the field itself. It's literally storing energy in what looks like empty space. Okay, so let's put an official name on this idea: magnetic field energy. It's simply the potential energy that's stored in a magnetic field when an electric current creates it. And the crucial part is that this stored energy can then be converted to do actual mechanical work, to make things move. So we've got our invisible spring all charged up with energy. Now for the most important part of the whole thing, going from field to force. How do we actually let go of that spring and get things moving? It's really a four-step dance. Step 1, the electric current creates the magnetic field. Step 2, that field stores up potential energy, just like our wound-up spring. Step 3, and this is the absolute key, we change the current, which changes the field. That sudden change releases all that stored energy. And finally, step 4, that released energy does the work, pushing and pulling to create rotation. That's the invisible link we were looking for. And hey, this isn't just my take on it. As our source material puts it so perfectly, the conversion of electromagnetic energy into mechanical energy is the fundamental principle of all rotating machines. The single idea is the heartbeat of pretty much every motor on the planet. So this isn't just some neat theory, right? This fundamental principle is quite literally powering our world. Let's just zoom out for a second and see how widespread this invisible force really is. Once you know what to look for, you see it absolutely everywhere. It's in the massive motors in electric vehicles, it's in wind turbines, which basically do the same thing but in reverse. It's in the tiny little motors spinning your computer's hard drive, the blender in your kitchen, the giant robots in a factory, and the drones flying through the sky. They are all powered by this one amazing idea:
So, at the end of the day, the big takeaway is this: that simple idea of an invisible spring, of storing energy in a magnetic field, isn't some abstract concept. It is a fundamental engine of modern civilization. It's happening right now, all around you, in dozens of devices that you count on every single day.
And that brings us to a final, pretty cool thought. For more than a century now, we've been mastering this one incredible trick, storing energy in invisible fields and then releasing it to do work. We've used it to build our entire world. So the real question is, what comes next? What's the next great machine this amazing invisible force is going to power?